Hello student, the question says figures 13.20 correspond to two circular motions, the radius of the circle, the period of revolution, the initial position, and the sense of revolution, that is clockwise or anti-clockwise, are indicated on each figure. So two figures are given to us. So time period is given, their radius is given. Here also time period is given, radius is given. What do we need to find? Obtain the corresponding simple harmonic motions of the x projection of the radius vector of the revolving particle P in each case. Let us see the concept behind this. If this is very important, this is taken as x-axis and this is taken as y-axis, and most of the time this would be my x-axis and this would be my y-axis. And imagine a particle performing a simple harmonic, a particle rotating in a circle. Let us consider a particle, and this particle is rotating in the form of a circle in this way. If this particle is rotating in the form of a circle, its projection, let us say this is the point. If the particle is located here, this will be the projection on the x-axis. So I will draw the projection with some other color. This will be the projection on the x-axis. As the particle is slowly traveling to a new position, we get a new projection on the x-axis here. Again, when it travels to a new position, again you will get a new projection on the x-axis here. So remember, as the particle is traveling in circular motion, its projection will be traveling in simple harmonic motion on the x-axis. The same logic could be extended in y direction also. As the particle is traveling in circular motion, its projection would slowly perform simple harmonic motion. Now you have to tell what will be the equation of projection. What will be exactly the equation of projections in this case? Let us try to understand the concept behind it. I did not explain this in much detail because by the time you reach these problems, you should know the concept of projections. So basically, if a particle rotates in circle, its projection would start to go in simple harmonic motion. Now our goal is to tell the equation of that projection. To tell the equation of projection, there are two things that we take. Imagine this is x and this is y. What is the direction of z? Direction of z would be outside. I will tell you why. If you take this is I cap and j cap, so I cross j cap would be k cap. That means basically anti-clockwise direction. I cross j is plus k cap. So if the body is going anti-clockwise direction, you will take positive omega, positive angular speed. And if it is clockwise direction, let us take negative angular speed. This is for convenience only. There is no rule that we have to always follow this. So if it is an anti-clockwise direction, we will take positive angular speed. If it is clockwise direction, we take a negative angular speed. Imagine this is the position P of the particle. And we measure the angle with respect to positive x-axis. Understood? Remember, you always measure the angle with positive x-axis and you travel. If let us take this value as omega t, some initial value phi. So if I take this value as omega t plus phi, and if I resolve this into two components, my x component would be, if r is the radius, my x component would be equals to r cos omega t plus phi. Similarly, my y component would be r sine omega t plus phi. Now the question is why this is r cos omega t plus phi, r sine omega t plus phi. I'll just explain detail here. Imagine that this is the center O. And the particle is traveling in circular motion. In this way, it is traveling in circular motion. Originally, my particle P is at an angle phi. Because of its rotation with angular speed omega, after time t, it went from this position to a new position. In this way, this is the new position of the particle. I will call this as p dash, and this would be equals to omega into t, because theta equals to omega into t. Angular displacement equals to angular speed into time. Then if I construct a triangle here, if we construct a triangle, we can see a right angle triangle. Once you see a right angle triangle, we can simply write, we have a right angle triangle, and the angle here is omega t plus phi. This is the radius of the circle. So adjacent side, so cos omega t plus phi equal to adjacent side by hypotenuse. Based on that logic, adjacent side would be r cos omega t plus phi. Similarly, opposite side would be r sin omega t plus phi. If you're like, I don't want to remember all this, is there any simple way? Generally, if any equation is given, if particle traveling in circular motion with constant omega is given, what we do is simply we will assume its x motion would be whatever is the radius into cos omega t plus its initial phase. Then similarly, y would be r sin omega t plus initial phase. Remember, this initial phase is measured from positive x-axis in anti-clockwise direction. And one more important thing is omega, if it is anti-clockwise, you will take it as positive. If it is clockwise, you will substitute negative. What do you mean by this? On solving these problems, you will understand it. Let us try to solve each one. So let us take the first one. I'm explaining this in detail, so listen to this carefully. If I take the first one now, okay, now let us try to, we know he's asking us the x equation. We know x equals to r cos omega t plus phi initial. What is the initial angle? If I start measuring from here, we have to go in anti-clockwise direction on. So from here to here, it is 90 degree. Again, another 90 degree, another 90 degree. So total 270 degree. So we got phi initial as 270 degree, or you can call this as 3 pi by 2. Okay, we got phi initial value. Now, is it clockwise or anti-clockwise? It is clockwise. Clockwise means omega is negative. So in place of omega, I can write minus 2 pi by capital T. Capital T is 2. So we can call it as minus pi. Let me just substitute it. So x equals to r cos minus pi t plus 270 degree. So we know r cos 270 minus pi t. Cos 270 minus theta value would be cos 270 minus theta would be, this is 0, this is 90, this is 180, this is 270. 270 minus theta would be in third quadrant. So you'll get minus r sin pi t. This will be the value. Or else if you only know till 180, I will do this in steps. So r equals to x equals to r cos 270 minus pi t. R, let us see, only know 180. I can write 180 plus 90 minus pi t. So if I take this all silver teacups rule, so here everything is positive. Here only sine is positive. Here cosine is positive. Here tan is positive. It is better if you know this. Right now I won't explain. So 180 plus theta. Okay, this should be t and this should be cosine. 180 plus theta would fall in the third quadrant. 180 plus anything would give us the same function. But in third quadrant, cosine would be negative. So you'll get minus r cos 90 minus pi t. Again, 90 minus theta would be sine. So minus sine pi t. This is step by step. But if you know it in one step, we can say x is equals to minus r cos pi t. So minus r value is given as 3. So minus 3 sine pi t. So this is the way to do it. I'll solve the same problem in another method, but I personally like this way to solve the problem. Simply use one expression and solve all the problems. Now let us try to find the values of y for the same one. For the same thing, if you need the expression in y direction, even though it is not asked, what will be the answer? For the same things, similarly, y equals to, we'll use r sine omega t plus phi initial. So again, r sine omega value, it is clockwise, so it should be negative, minus 2 pi by 2 into t plus initial is, we have seen it, 3 pi by 2. So r sine, that is 270 degree minus pi t. Sine 270 minus theta is minus cos theta. So minus r cos pi t. So the answer for this would be minus r cos pi t. So since r is 3 centimeter, so minus 3 cos pi t, and you have to tell in centimeter. This y value is measured in centimeter. Here the x value also is measured in centimeter. This is how we are supposed to solve it. But let me tell you, this is just one way to solve the problem. There is one more way to solve the problem. We will discuss that after explaining this problem also. Okay, let us write both x and y equations for this. This is the original position, initial position of the particle. We know we have only one equation, x equals to a, that is r cos omega t plus phi initial. We'll just check whether it is clockwise or anti-clockwise. So this is anti-clockwise, that means omega is positive, and we can simply write omega equals to 2 pi by t value is 4. So we can write this as pi by 2. Next, what is the initial phase? The particle is located here. If I measure from the positive x-axis, initial phase is phi. So phi initial is pi. Quickly substitute it. X equals to r cos pi by 2 into t plus pi. If I do that, I will get simply cos 180 plus theta is minus sine theta. So it would be minus r, sorry, 180 plus theta would be cos only. Cos 180 plus theta is cos theta. So r cos pi by 2 into t. This method is most useful if you know 180 plus theta, 180 minus theta and all that. If you don't know that, these methods won't be that useful. So this is one way to solve that. Similarly, we can tell the y equation also. Y equals to, this is 2 sine, we just found pi value is pi by 2 into t plus this value is pi. So sine 180 plus theta is minus sine theta. So minus 2 sine pi by 2 into t, because 180 plus theta would fall in third quadrant. So even cos sine both are negative. So this will be the y and x coordinates. To whom this method is useful? If you know the values of sine 180 plus theta, sine 180 minus theta, cos 180 plus theta, cos 180 minus theta and all that. If you don't know that, there is another way to solve these problems. Remember, this will be very useful if you know how to solve sine 180 plus theta, cos 180 plus theta, sine 180 minus theta, cos 180 minus theta and so on. 270 plus theta. But let us look at method to solve these problems. Let me take the same question. Here, this is the original location of the particle. After time t, where will the particle would go? It will slowly travel. Here it will be located. So this is the new location of the particle after time t. So I draw an arrow here. If I draw an arrow, this would be radius. What is the angle covered? If omega is the angular velocity, I can call this as omega into t, and r will be the radius. Then I can construct a triangle here. If I slowly construct a triangle, I think I made a small mistake. It is going in anti-clockwise direction. So just let us move it to this location. If I move it to this location, then this would be equals to omega t. This is r, and this one also would be r. Based on that logic, if this is omega t, if I draw a line here, I can see a triangle forming. And in this triangle, if I represent it here, if this is omega t, this angle would be omega t, and this is my r. This represents the x part, this represents the y part. So if I try to find unknown, we know opposite side would be sine. So this unknown value would be equals to, since it is on the left side, I can write minus r sine omega t. So simply the expression for x would be minus r sine omega t. R value is given as 3 centimeters. So minus 3 sine 2 pi by 2 into t. So we will get minus sine pi t. Similarly, what will be its y coordinate? It is on the negative y side. So similar thing, y equals to minus r. This side is attached to omega t. So it would become minus r cos omega t. So you'll get minus 3 cos pi t, because omega is same. This has to be in centimeter. This has to be in centimeters. If you understand this method is also very easy. But I personally like this because I know how to quickly tell the values of cos omega t and sin omega t and so on. Now let us go for this problem. The second one. If you look at this second one, same thing. Originally, the particle is here. Imagine after some time, the particle traveled and reached a new location somewhere here. And since it is traveling with omega, this becomes omega t. Now again, I'll quickly construct a triangle here. This is one. This is another one. And this is another side. So if I construct a triangle, this is r, this is omega t. Now, what will be this value? This is on the negative side. So we can write x is equals to minus r cos omega t, because the side to which theta is attached would be cosine. And one more is that this is on the left side, negative x-axis. So that's why this minus r. So minus 2 cos pi. This is 2 pi by 4 into t. So you'll get minus cos pi by 2 into t. Similarly, y also would become minus r sin omega t. So it would become minus 2 sin pi by 2 into t, because it is also on the downside. This is also on the negative side. So this is another quick way to solve the problem. But if you know 180 degree and 90 plus and all that, you can use this blunt method to solve the problem. So hope you understood both the methods. Try some more example questions and other questions that are given. Should be able to do this easily. But try to practice both the methods every time. Thank you.